Yeah, we're getting ready to do this. Alright, so we're going to start reviewing. I think most of these are just videos. Alright, so what we're going to do, not every day, but some days when we're doing Study Island, there'll be a lesson that we'll do each day. It's just a review lesson, and then sometimes there's videos, sometimes there's not. But then when you go back in, you'll have an assignment in Study Island, and you have to do a minimum of 10 problems. But if you don't like your grade after the 10 problems, you can go back in and redo. So today you'll have a lesson on rational exponents, and you can go back in and redo as many problems as you're not redoing the same problems, but you can do that lesson over and over until you get the grade that you want. Once you get, it'll show over here, I'm not exactly sure how the student part looks, but once it gives you your score, it'll give you have y'all been Study Island before? I think you did, like in middle school. It gives you ribbons over here. And if you get up to a 70%, an average at 70%, not if you get, say maybe you did it the first time and you only got 1 out of 10 right, and you did it another time and you got 5 out of 10 right. Well, those things get averaged together, but once you get a certain level, then you get a ribbon, which is around 70%, and if you get to 70%, then you'll get, I'll put it in as a 100, otherwise it just goes in as whatever you got, but we'll get to that part. Get back to the lesson. Do what? You hated Study Island? Well, there's no games on it. It's not middle school Study Island anymore, that's for sure.
Rewrite the radical expression using rational...
Alright, so this is just Khan Academy. I just found these videos because he does different examples. If you want me to stop it so you can copy it, I'll stop it too, and then I'll try to turn it up and turn one of the lights off.
Rational exponents and simplify. So here we have the 4th root of 5a to the 4th b to the 12th power. And the key thing to realize here is the 4th root of something is the same thing as that something to the 1/4 power. Or in particular, or in general, the nth root of something is the same thing as that something to the 1/n power. So we can just apply that over here. The 4th root of all of this is equal to 5a to the 4th, b to the 12th power, all of that to the 1/4 power. And then we also know if we take the product of things and then raise them to some exponent, that's the same thing as raising each of the terms in the product to the exponent first, or each of the things that we're taking the product of to that exponent, and then multiplying. So let's do that. So 5, so this is the same thing as 5 to the 1/4 power, times a to the 4th to the 1/4 power, times b to the 12th to the 1/4 power. Now, 5 to the 1/4, I don't know what that is, so I'll just keep that as the cube root. Well, we could leave it as 5 to the 1/4, and that's not simplified, or we could just rewrite it again as the 4th root of 5. A to the 4th to the 1/4 power. If you raise something to a power and then another power, and raise that to another power, that's the equivalent of raising the a to the 4 times 1/4 power. So let me just write that down. This is, so times a to the 4 times 1/4 power. And then finally, this right over here, using the same exact exponent property, this is b to the 12th times 1/4 power. And so all of this simplifies to, and I'll change the order here, so you have the 4th root of 5, and then you have a to the 4th times 1/4 power. So this simplifies to a to the 1st power, which is really just the same thing as a. So that's just a. And then we have b to the 12th times 1/4 power. Well, 12 times 1/4 is just 3. So that's b to the 3rd power. So it's a b to the 3rd power times the 4th root of 5. Rewrite the fourth root of 5.
So stop it right there in case anybody needs to copy it for us. Well, you shouldn't be on study hour right now. I'll tell you after we get through. You shouldn't have your Chromebooks out right now. So. Okay, need it? Okay, so basically what he's done, when you raise a power to a power, like that 4 to the 1/4, remember a power to a power, you multiply, so that's where he multiplied that 4 times 1/4 and multiplied 12 times the 1/4. Another one here.
So a few videos ago, I told you that anything to the 0th power is equal to 1. So x to the 0th power is equal to 1. And I gave you one argument why this is the case, that, I used the example of, if we have 3 to the first power, that is equal to 3. 3 to the second power is equal to 9. 3 to the third power is equal to 27. So every time we decrease by a power, we're dividing by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. Then 3 divided by 3 is 1. And so that should be what 3 to the 0th power is. So that's one way to think about it. The other way to think about it is that we need this for the exponent properties to work. For example, I told you that a to the b times a to the c is equal to a to the b plus c. Now, what happens if c is 0? What happens if we have a to the b times a to the 0? Well, by this property, this needs to be equal to a to the b plus 0, which is equal to a to the b. So a to the b times a to the 0 must be equal to a to the b. If you divide both sides of this times a to the, let me rewrite this. A to the b times a to the 0, if we use this property up here, must be equal to a to the b, right? B plus 0 is b. If you divide both sides by a to the b, you divide both sides by a to the b, what do you get? The left-hand side, you're left with just a to the 0, right? These cancel out. A to the 0 is equal to 1. And you could use a similar argument in pretty much all of the exponent properties, that we need anything to the 0th power to be equal to 1. And it also makes sense as we divide by 3 each step as we decrement our exponent. And it keeps working. When you take 3 to the negative 1 power, 3 to the negative 1 power, we saw in the last video that that's equal to 1 over 3 to the first power, or 1/3. So once again, from 3 to the 0 to 1/3, you're dividing by 3 again. So it really makes sense on some level that 3 to the 0th power is equal to 1. But that leaves a little bit of a gap. What about 0 to the 0th power? This is a very strange notion. 0 multiplied by itself is 0 times. And it depends what context you're using. Sometimes people will say that this is undefined, but many more times, at least in my experience, this will be defined to be 1. So defined to be 1. And the reason why, even though this is completely non-intuitive, and you could type in 0 to the 0th power in Google and it'll give you 1. The reason, even though this is completely non-intuitive, the reason why this is defined to be this way is that it makes a lot of formulas work, and in particular the binomial formula works for your binomial coefficients, which I'm not going to go over right here, when 0 to the 0th power is equal to 1. So that's an interesting thing for you to think about, what that might even mean. So let's talk about some of the other properties, and then we can put them all together with a couple of example problems. I told you in the last video what it means to raise to a negative power. A to the negative 1 power, or maybe I should say a to the negative b power, is equal to 1 over a to the b power. So just to do that with a couple of concrete examples, 3 to the negative 3 power is equal to 1 over 3 to the third power, which is equal to 1 over 3 times 3 times 3, which is equal to 1 over 27. If I were to ask you what 1/3 1/3, let's say to the negative 2 power is? Well, this is going to be equal to 1 over 1/3 to the second power. You get rid of the negative and you inverse it. So this is going to be equal to 1 over, what's 1/3 times 1/3? 1/9, which is equal to, this is 1 divided by 1/9, the same thing as 1 times 9, so this is equal to 9. And this makes complete sense, because 1/3, remember, 1/3 is the same thing as 3 to the negative 1 power, right? The 3 to the negative 1 is 1, this is equal to 1 over 3 to the 1 power, which is the same thing as 1/3. So if we replace 1/3 with 3 to the negative 1, this is 3 to the negative 1 to the negative 2 power. These two things are equivalent statements. And if we use some of the one of the properties we learned in the first video, we can take the product of these two exponents. So this is equal to 3 to the negative 1 times negative 2, which is just positive 2, which is equal to 9. So it's really neat how all of these exponent properties really fit together in a nice, neat puzzle, that they don't contradict each other. It doesn't matter which property you use, you'll get the right answer in the end, as long as you don't do something crazy. Now the last thing I want to define is the notion of a fractional exponent. So if I have something to a fractional power, so let's say I have a to the 1 over b power. I'm going to define this. This is going to be equal to the bth root of a. So let me be very clear here. Let me be very clear. Let me make it with some numbers here. If I said 4 to the 1/2 power right there, this means this is equivalent to the square root of 4, which is equal to, if we're taking the principal root, this is equal to 2. So if I were to take, let's be clear, if I were to take 8 to the 1/3 power, this is taking the cube root of 8. And this is on some level one of the most sometimes confusing things in exponents. Here I'm saying what number times itself 3 times is equal to 8. So if I said that x, let me do this. If I were to say that x is equal to 8 to the 1/3 power, this is the exact same thing as saying x to the 3rd power is equal to 8. And how do I know that these are equivalent statements? Well, I could take both sides of this equation to the 3rd power. If I take the left-hand side of the 3rd power and the right-hand side of the 3rd power, what do I get? On the left-hand side, I get x to the 3rd. On the right-hand side, I get 8 to the 1/3 times 3, which is just 3 over 3, which is just 1. So if x is equal to 8 to the 1/3, if x is equal to 8 to the 1/3, what is x? Well, 2 times 2 times 2 is equal to 8. And there's no really easy way, especially once you go to like the 4th root or the 5th root and you have decimals, of calculating these. You probably need a calculator most of the time to do these. But things like 8 to the 1/3 or 16 to the 1/4 or 27 to the 1/3, they're not too hard to calculate. Now so this right here, let me be clear, is 2. Now let's make it a little bit more confusing. Let's make it, what is 27 to the negative 1/3 power? Well, don't get too worried. We're just going to take it step by step. When you take the negative power, here, this is completely equivalent to 1 over 27 to the 1/3 power. These two are equivalent. You get rid of the negative and take 1 over the whole thing. And then what is 27 to the 1/3 power? Well, what number times itself 3 times is equal to 27? Well, that's equal to 3. So this is going to be equal to 1 over 3. Not too bad. Now I'm going to take it even to another level. Make it even more confusing, even more daunting. What is, now let me do something interesting. What is 8 to the 2/3? To the 2/3 power. Now that seems a little bit scary. And all you have to remember is this is the same thing, using our exponent rules really, as 8 squared to the 1/3 power. How do I know that? Well, if I multiply these two exponents, this is 2/3. So 8 to the 2/3 is the same thing as 8 squared, and then the third root of that. You could view it the other way. This should also be equal to 8 to the 1/3 power squared. Because either way, when I multiply these exponents, I get 8 to the 2/3. Let's verify for ourselves that we really do get the same value. So 8 squared is 64. We're going to take that to the 1/3 power. Down here we have 8 to the 1/3. We already figured out what that is. That's 2, because 2 to the 3rd power is 8. So this is 2 squared. Now what is 64 to the 1/3? What times itself 3 times is equal to 64? Well, 4 times 4 times 4 is equal to 64. Or 4 to the 3rd is equal to 64. 4 to the 3rd is equal to 64, which means that 4 is equal to 64 to the 1/3. So this is equal to 4. And, lucky for us, 2 squared is also equal to 4. So it doesn't matter which way you do it. You could take the square and then the 3rd root, or you could take the 3rd root and then square it. You're going to get the exact same answer. Now, everything I've been doing has been with actual numbers. Let's do a couple of problems that just, bring everything we've done together using variables. So let's say we wanted to do a few expressions, and we want to make sure there are no negative exponents in the answer. So let's say I had x to the negative 3 over x to the negative 7. Well, there's a bunch of ways we could view this. We could view this as equal to x to the negative 3 times 1 over x to the negative 7. And what is 1 over x to the negative 7? This is the same thing as, this right here is the same thing as x to the 7th power, right? If you have 1 over something, you can get rid of the 1 over and put a negative in front of the exponent. But if you're putting a negative in front of a negative 7, you're going to get x to a 7. So this thing can simplify to x to the negative 3 times x to the 7th power. And then we can add the exponents, and that is x to the 4th power. Now another way, a completely legitimate way we could have done this, is we could have just subtracted the exponents. We could have said, well, gee, this is the same base. This is going to be x to the negative 3 minus negative 7 power. Well, negative 3 minus negative 7, that's the negative 3 plus 7, which is equal to x to the 4th power. And then one final way we could have, actually there's more than one final way we could have done this. You could have said x to the negative 3 over x to the negative 7, sorry, not negative x, over x to the negative 7. Well, x to the negative 3 is the same thing as 1 over x to the 3rd, that's that term right there, times 1 over x to the negative 7. So this would have been equal to 1 over x to the 3rd times x to the negative 7. You can add the exponents, so that's equal to 1 over 3 minus 7 is x to the negative 4. And then this, if we just get rid of the inverse, we take the inverse of it, we can put a negative in front of this negative, making it a positive. This is going to be equal to x to the 4. So no matter how we did it, as long as we're consistent with our rules, we got x to the 4th.
Out of all these different ways he's showing you, this is the one we've talked about the most. When you divide variables or numbers, whatever it is, you subtract these exponents. So this is the one that we focused on when we originally did it. The other way that I showed you was, remember anytime you have a negative exponent, you just move it. So if it's in the numerator, you put it in the denominator, and if it's in the denominator, you put it in the numerator. So the other way I showed you was, all right, you move this to the denominator, so x to the 3rd, and move this to the numerator, x to the 7th, so you have x7 over x3, and then you subtract against the 7 minus 3 4. But it doesn't matter, he shows you a lot of different ways. This one, or this one, to me, makes it more complicated than just saying, let's just subtract these two things.
Let's do one more slightly hairy one, and I think we'll be done for now. Let's say we have 3x squared times y to the 3/2 power, and we're going to divide it by x times y to the 1/2 power. Well, once again, this is the same thing as 3 times the x terms right here, so 3 times x squared over x times y to the 3/2 over y to the 1/2. Y to the 3/2 over y to the 1/2. Well, this is going to be equal to 3 times, what's x squared over x? Or x squared over x to the first power. That's going to be equal to x to the 2 minus 1, 2 minus 1. And then this is going to be times y to the 3/2 minus 1/2. So what does the whole thing become? It becomes 3 times x, 2 minus 1 is just 1. I can just write x there, times 3/2 minus 1/2 is 2/2. So that's y to the 2/2. 2/2 or 2/2, that's just the same thing as y. So this is equal to 3xy. Anyway, I encourage you to do many, many more examples of that, but you'll see that just using the rules that we've been exposed to in the last few videos, you can pretty much simplify any exponent expression.
You might need that. I forgot my stuff. Couldn't read it.
The colors large and black.
Do I need to go back and stop it? And does anybody want to write it down? Stop that one. That's wrong. Alright, so what we're going to do are just practice problems. And the practice problems will be just like the ones that you'll get on your assignment, on the homework. So here's the type of problem. And here you got your calculators. Turn on on. This should be something y'all should know by now. Forget it, it's very beginning of the class. Joseph, you need to pay attention or go to Mr. Brenton during one or the other. Alright, so it's got simplify the following. 32 to the 4/5 power. Now, we could go through everything that he did there where he would say that's 32 to the 4th power raised to the 1/5, but on your test, you're going to have your calculator. There's not a non-calculator part. So in my mind, the easiest thing for us to do is just learn how to put this right in the calculator. No, not yet. So all we're going to do is practice putting this right in the calculator. I mean, it's an easy thing to do, but you got to know exactly where to go. Let me clear this out. So you're doing 32 raised, and because it's a fraction, you've got to put it in parentheses. So raised to the 4 divided by 5, and then close your parentheses. Now, if there was something else that we needed to put in there, in order to get out of this exponent position, you've got to use your right arrow to go back down. And there's not, in this case, but if there was, you would use that arrow. So, Sydney says she knows the answer. 16. Sometimes it depends on how, because you've got it all in the exponent, sometimes when you'll have variables up here, you just have to be careful. I just always tell everybody, anytime you have fractions, just put parentheses just in case. So, 16 right here. What? Well, that one was pretty simple. So we'll go on to the next one. Alright, now, what is this one? So, again, now what? Is that better? Yeah. Okay. Alright, now, you're going to have to do this in parts. So, somebody do the 1 over 2 to the 5th. Somebody tell us that part. 1 over 2 to the 5th. 1 divided by 2 to the 5th. And we're gonna do this in parts. You don't wanna try to put all this in at the same time.
I got 0.
Make it a fraction, math 1 1, math 1 enter. We'll do 1 over 32. Okay, so we've got originally, I apologize, so this writing's not gonna be the greatest while I'm sitting over this mouse, but instead of having to go back and forth, so 1 over 32. Alright, so now, the square, so do parentheses, and somebody do the square root of 16 to the 16th power, times, and then somebody do 8 to the 8th, and then somebody do 4 divided by, or 4 to the 21st power. So that's 3, and there's gonna be 3, 2 of these are gonna be really big numbers. Square root of 16 to the 16th power, so you'll have to,
4.
like that.
4, 2, 9, 4. Yeah, that's what I got.
Yeah, okay, so as long as you got it on your calculator, so when I come over here, I can write it. Then we got parentheses, alright, tell me what it was,
4, 2,
4,
9, 4, 9, 6, 7, 2, 9, 6. Oh, no,
alright, now, what was 8 to the 8th, who has that one?
it's 1, 6, 7, 7, 7, 2, 1, 6.
Divided by 4 to the 21st?
4, 20.
Is it have an E on the end of it?
Yeah.
Okay, so listen, but that's saying it's a really, really big number, so let's do this. Let's put this in there. So here's the way I would do it on the calculator. I would say the square root of 16 to the 16th power, and you get this. And then we're gonna do times 8 to the 8th. So you hit times 8 to the 8th power, and then hit enter. So you should be doing this on your calculator with us. So times 8 to the 8th, and now divided by 4 to the 21st power. So divided by 4
I got,
to the 21st power.
I got 1,
Is that all you got? 16,384? And do square root of 16 to the 16th, right here, times 8 to the 8th, divided by 4 to the 21st hour. So we multiplied the first two, and divided by 4 to the 21st.
I got it.
Unless you're typing it in wrong, but I'm not sure. Did you get this? Okay, so then times 8 to the 8th, you get that?
Yeah, I didn't say it.
Jackson, you getting it? Kyle, you getting it? Good? Okay, so now we've got all of that number, that 16,000, raised to the 1/2 power. So we're gonna come back over here and hit raise, because I'm just taking that number, so I just hit the 2 button, raise, and I'm gonna put it in parentheses again. 1 divided by 2. But really, this is just the square root, is what we're doing. I'm gonna hit enter. And then the last part times that 1 over 32 that we had. So you gotta put times, it's a fraction, so 1 divided by 32. And this part, it wouldn't matter if you did the parentheses or not, because you're multiplying by 1. But I'd go ahead and put it in parentheses anyway. Is it 4? Right now, I've I've not seen any this difficult on a math two test. I'm not saying that there won't be. I didn't,
Yeah, that's,
so, I mean, I don't know, but it's, everything's right there. You just gotta, go through the process, being careful. Alright, this one's just asking, so this is one that you will see on your math two test. This is one that's very typical. Which of the following is equivalent to 7 to the negative 2/3? So the first thing, just remember, that negative means put it in the denominator. Or if it's in the denominator, put it in the numerator. Just switch places. So this is really 7 over 2/3 to begin with. So this is 1 over 7 to the, that looks like a kindergartner's handwriting. 1 over 7 to the 2/3. Well, then this 7 to the 2/3, that's the same thing, which is what he was saying was 1 over 7 squared raised to the 1/3 power. So 2 times 1/3 is 2/3. So that's the same thing. Or you could write it as 1 over 7 to the 1/3 power squared. Whichever way you want to do it, doesn't matter. But you've got to start thinking about these fractional exponents as roots. Because the 1/3 power, you have x to the 1/3 power, that's the same thing as the cube root of x. So this is really the cube root of 7 squared. The cube root of 7, so it's 1 over the cube root of 7 squared, and 7 squared is 49, but I doubt they put it that way. So, right here, 1 over the cube root of 7 squared. Now, let's say that you didn't know how to do all this. What would be another way to do this? Could you put that in your calculator and come up with an answer? You put 7 to the negative 2/3 in there, and it's going to give you an answer, and then go through each one of these and figure out which one equals that. You could do that. Okay, you could do 7 to the negative 7 raised to the negative 2 divided by 3. And you'll get this answer. But you gotta be careful how you put it in there. Did I put it in there right? I didn't divide it by, sorry. I didn't do 2 to the power. Yep, sorry, that was my fault. 7 to the, sorry, I hit the wrong button. Negative 2 divided by 3 power. There you go, that's what you got in there. So it gives you that. And you can make it a fraction, it may or may not give you a fraction on that. So it won't give you a fraction, but that's okay. So then take all of these answers and see which one will give you that same decimal. So you could do it that way too. Doesn't matter, but you could do it that way. Jody, you need to go to the office and wake up, or go to the bathroom and wake up, or, alright, you stay awake then. So go. Alright, so same thing, try this one. Rewrite the 5th root of x to the 4th power. So the 5th root of x to the 4th power. Very, very similar to the one we just did. You can't put this one in the calculator because it's got variables. You have to know how to write it using these exponent rules. So the 5th root, I just told you, the 5th root gives you fractions. Any guesses? D? Okay, why did it go to the denominator? Was there any negatives up here? No, so it isn't B. D? Okay, well, let's look back at this one. 2/3, 7 to the 2/3. The 3 was the fraction, that's the cube root. The top number is the one that was raised to the power. C. Remember, this is the one that's a fraction. This is one that's going to go in the denominator, so it's C. Alright, same thing. Again, think about it using these exponents. Or the exponent rules. What does that negative do? It moves it to the bottom. So you know it's going to be this one or this one. because that negative puts it in the denominator. So it's gonna be one of these two. So then you've got to decide, all right, and this is my recommendation or suggestion. Look at the denominator. That denominator is gonna be where the root is. Right here. Or right here. That's a square root, that's a cube root. So that denominator is a 3, so that means it has to be this one right here. Right, another one. Just put it right in your calculator. 27 to the 2/3 power. Those are easy ones. I doubt you would get something that simple on test, but I'd be happy if I did. So really, that's the cube root of 27, 3, and 3 squared is 9. Got that 9? Okay. Another one. You're just changing the form. So remember, this is the root. There's only one answer that has a cube root on it. Hey, that's it. Alright, another one where you got this times this divided by this. So let's talk about how we're going to put this in there. So we're going to do the numerator first. So the cube root of 23 to the 4th. So does anybody remember how to get cube root? You go to math. Here's the cube root. Cube root, what was it, 23 to the 4th. So the cube root is 23 raised to the 4th power. Now you can use your arrow, right arrow, and get out of it, but you still got to get out of this cube root. See how I'm outside the cube root now? So I had to hit my right arrow twice. And then times square root of 100 to the 3rd, and the square root of 100 to the 3rd. So that's my numerator. So I'm just going to hit enter from right there. Just get my numerator. I don't really care what that number is. I just know that's my numerator. So now I'm going to put divided by, and because there's two things in that denominator, I've got to put it in parentheses. So I got to tell the calculator, hey, this whole thing is in the denominator. So when you say divided by, put parentheses, and then it's 10 to the 5th power. 10 to the 5th. Use your arrow, right arrow, to get out of that. So you go down here. Times the cube root of 23. So the cube root 23, and I'm going to close my parentheses. Anybody else did that? 22.3, was that an answer? So it's not hard, it's just a matter of knowing how to put it in the calculator, though. Alright, another one. What is it? Well, remember, this is the fraction, so that means it's a square root. You can put that one right in your calculator. 169 is the square root of 169 is 13. One of the time tables, you know. Alright, which is equivalent. The negative means it's going to be in the denominator. That means it's got to be one of these. Now, your fraction, your denominator right here, means that's the root. That's the 4. That's it. That's the only kind of questions you're going to have on that. Can you handle that? Yours will be June 1st. First block. Alright, so what you need to do is go into Study Island. It is your first name dot last name. Let's see. Let me get back to here just in case. Some of you might have had, let me make sure I don't have it printed out. think everybody, yeah, it's first name dot last name, all lowercase with a 1 out by it, and then remember your password 123456. Unless you wanna change it, but, so first name dot last name, and you should have, you'll go to my classes. And you should have, there's several assignments in there, but this is the one. Let me change this one. 1, 2, 3, 4, 5, 6. You should have a rational exponents homework. Remember, you have to do 10 of them. And just so everybody understands, I can go to this screen right here and it will tell me exactly what number you're on and what you're doing and what your grade is. So if you think that you're sitting there just because I can't see your screen, I don't know what you're doing,
Are we doing the main
you're doing the, yeah, make it, because tomorrow's when it'll be due. But you can do it as many times as you need to do. So you're going to rational exponents. You gotta do at least 10. But you can do as many as you want until you get the grade that you need. I don't know, what grade do you need? What grade do you want? That's your choice.
You don't have to.
Whatever grade you get, what's going in the grade book, so that's your choice.
So we would practice that.
Practice mode. And you won't all have the same questions, so. Your password was 1, 2, 3, 4, 5, 6, so I just pulled it up. Lowercase. First name, dot last name, all lowercase with a 1 at the end of it. So it'd be Joseph.Nazareth